So today we're looking at learning targets 2.3 and 2.4 because they kind of go together. Now on the test they'll be assessed separately, although you'll really be doing kind of this things that are very connected to each other. So, writing an equation in slope-intercept form to model a linear relationship, and then looking at that equation or looking at the relationship or looking at a graph and explaining where you see the start value, the y-intercept, or the rate of change, which is the slope. So, it says a minivan is 220 miles from its destination in Flint. It begins traveling towards Flint at 72 miles per hour. Write a recursive routine that models the van's distance from Flint. Every single time you write a recursive routine in this class, without fail, your recursive routine is always the words start with and then go find your starting value. Well, it wants distance from Flint. It says it starts 222 miles from Flint. So start with 220, then we're going to put ANS because that's the way the recursive routines work on your calculator. Now, are you taking the previous number and adding something to it? Are you taking the previous number and subtracting something from it? In this case, it's traveling towards Flint. So after 1 hour, it's going to be less than 220 miles away. So answer minus. And how much is it traveling every hour? 72 miles. So my recursive routine, start with 220, then take the previous answer, so ANS, minus 72. An expression to find the distance it will be from Flint after 3 hours. Well, I'd start at 220, and I'd have to subtract 72 3 different times. So that's the same thing as 72 times 3. Because I don't want to write minus 72, minus 72, minus 72. Same thing as this. To write an equation to model the van's distance, think about it would be very similar to this. It would be y equals 220 is my starting value, and thinking about what I did here to calculate after 3 hours, I'd be subtracting 72 times x. Because this time they told me 3 hours, but what if it was 2.5 hours or 1 hour? I'm going to take that 72 and multiply it by 2.5, or 72 and multiply it by 1. This only works if I carefully define what x and y are. Y is usually the easier one to define. What we're really calculating here is the distance from Flint. So y is distance, and in this case the distance is in miles from Flint. X is where people mess up generally. They want to say x is the miles per hour. No, x isn't the miles per hour. We know 72 miles per hour. That's not a variable. But think about what we did when we put the 3 in here. The 3 told us how many times we were going to have to subtract the 72. The 3 was the actual number of hours that the van had been traveling. So x is the number of hours that the van's been traveling, not the miles per hour. The miles per hour is 72. That's not a variable. It's the number of hours. So if I take 220 and I subtract 72 times the number of hours this thing's been traveling, I will get how far it is from Flint. Now, how do the starting value and the rule of the recursive routine show up in the equation? And how would they show up in the graph? So the starting value of 220 is the constant in the equation. And on the graph, it's the y-intercept. So it's and the y-intercept on the graph. So I have to say where it's coming in both places. The rate of change, the rule in this case, the rule is the coefficient, that's the number in front of, is the coefficient of x in the equation. Now it's the slope on the graph, but don't just say it's the slope, because somebody may not understand what that means. And on the graph is the rise over run. Slope is the rise over the run. It tells me where my line goes after I plot my first point. Now, the slope-intercept form of an equation is y equals mx plus b, or sometimes, like the one that we just wrote, we wrote y equals b plus mx. Traditionally, your x term goes before your constant, but the thought process as we were writing this is, where do I start? What happens next? Which is why it was kind of written in reverse order. And m is the slope, b is the y-intercept, which means where the line crosses the y-axis when I graph it. The independent variable, in this case, it's our input. It's also our x for this particular thing. My dependent variable is my output, which in this case is my y. Now the reason they're called this, the value of y depends on the value of x. So y is the dependent variable because the distance from Flint depends on how many hours the van has been traveling. That's why it's in that order. And you've seen those in science as well. Thank you.